Today we will be finding the greatest common divisor, also known as the greatest common factor. We'll also see some problems in which we'd end up using a problem like this, or the greatest common factor for. So let's take these numbers to start with, 45 and 75, and let's break them down to the prime factorization. So always look for a common factor that you might see in these numbers. And if you don't see a really big number, maybe start with something you do see. Remember how we talked about divisibility rules. If the number ends in 5, I'd go ahead and divide each number by 5. And so I do that. I get 5 and 9 here, and I go ahead and break the 75 down, and that makes 5 times by 15. So they both have a 5 in common, but I can continue breaking these numbers down. So I'll bring down the 5 and the 45. 9 breaks down to 3 times 3. And so over here, I'm going to bring down this 5 and break this 15 down to 5 times by 3. So what I see is that both of these terms here, the 45 and the 75, have a common factor of 5. This one has 2 5s, but this one only has 1. So we're talking about common factors. And so 3 is another factor. This one has 2, but this one only has 1. So we can only use 1 3 and 1 5 as a common factor. Well, you multiply those two numbers together, and that makes 15. So the greatest common divisor is 15. That's what they share in common. So what that means is I can divide both of those numbers by 15. It's the biggest number that is a divisor of these two values. Well, here we have 3 numbers. So what I look at is before I go ahead and just try to factor it, like maybe dividing by 2 because they're all even, well, I see that I know that 8 goes into 24. I know 8 times 3 makes 24. I know 8 goes into 56. So I'll break that down to 8 times by 7. And I know that 8 goes into that 72. So I'll break that one down to 8 times by 9. And so if you see a common factor, like 8 in that case, then go ahead and divide them by 8. And that way you've got some of the work done for you already. So now you need to look at these terms that are left over. Here we have a 3, a 7. Those are both prime. The 9 we could have broken down a little bit further to 3 times 3, but it doesn't help us out because you see here how we have a common factor of 8. Here we have a common factor of 8. Here we have a common factor of 8. But that's it. See, this one has a 3, and this one does not. It has a 7. And so that 3 is not a common factor between all 3 of these terms. So the greatest common divisor in this case is just 8. Now look at the next one. I'm going to do the same thing. I look for a common factor between all of those numbers. So I'm going to start with the 14, and I see that it would be broken down to 7 times by 2. Well, the 35, I could break down to 7 times by 5. 56, I see it's 7 times by 8. And 77, well, I see that's 7 times 11. So even though I could break the 8 down, it doesn't help me out because 2 is the factor of 8. It's a factor of 8. It's actually 3 2's being multiplied. And since 5 and 11 don't have 2's in them, their factors are not 2's, then that means that 7 is the only common factor between all of the numbers. So the greatest common divisor here, or greatest common factor, is 7. Well, here are some problems in which we would actually use this greatest common divisor for. So it says Carvin is preparing identical breakfast gift sets. There are 18 boxes of pancakes and 27 jars of jam. So what is the greatest number of gift sets he can prepare using all of the pancake mix and all the jams? So let's write down pancakes. And over here we have jars of jam. And let's write their numbers. So pancakes was 18 boxes. Jam was 27. And let's break these numbers down. So I see that 18. Now as I look at these, look at the common factor. What goes into 18? And then what also goes into 27? That's the same. Well, I know 3 goes into those numbers. But I also see 9. 9's the bigger number. So that's what I'm going to start with. So I see 9, so I'll start with that. And I see that 2 and 3 are already prime, so we found it. So what this means is they both have a 9. So that's the greatest common divisor. But now they're asking us to actually use some units that go along with it. So what we would say is there we can make 9 gifts. And in those 9 gifts, that means that each of those 9 gifts would have 2 pancakes, and it would also have 3 jars of jam. So we'll say 3 jams. So that's what that represents. So the 9, the common factor of 9, just tells you how many groups that you could have of 2 pancakes and 3 jams. So 9 gifts is the answer. But what that means is each of those 9 gifts would have 2 pancakes and 3 jams. Well, let's take a look at the next one. It says Amelia is decorating identical frames. She has 75 red feathers. Okay, so let's just write down feathers here. And she has some blue tiles. So we'll just write down tiles. Okay, so there are 75 feathers and 30 tiles. So what we want to find is the greatest number of frames. So the greatest number of frames she can decorate using all the feathers and all the tiles. So this is where we use the greatest common factor, or greatest common divisor. So I see that each of these numbers could be divided by 5, but there is a bigger number. So if you didn't see that right away, let's just divide them by 5. 5 times 15 makes 75. 5 times 6 makes 30. Well, you'd have to continue breaking it down, because 5 times 3 makes 15. Bring down that other 5. Here, break down the 6 to 3 times 2. Bring down the 5. So now we've broken it down to the prime factored form, so I see that each number has a 5, but each number also has a 3. So 5 and 3 are the common factors. Well, you multiply those, and what that makes is 15. So we can make 15 frames is what we were making. We were making frames with the feathers and the tiles. So 15 frames, and what would that consist of? Well, it would consist of, in this case here, we have 5 feathers. So each of those frames, say each frame would have 5 feathers, and it would have 2 tiles. So that's what that would represent. Well, let's take a look at our next one. It says the fabric store is the fabric is sold in stores from bolts that are 45 or 60 inches wide. And then it says, what is the width of the widest strips of fabric you can cut from either bolt without wasting any of the fabric from each strip? And each strip is the same width as well. So we'll take the 2 different types. So we've got the 45 inches, and then we also have the 60 inch. So we're going to break these down. So again, if you didn't see the big number that goes in there, then just start dividing by what you know. Maybe 5, because this one ends in 5, this one ends in 0. So if I divide by 5, that gives me 9. Here I divide by 5, that gives me 12. But 9 and 12 have common factors, so we need to break those down further. Bring down the 5, this would be 3 and 3. Bring down the 5 here, we'd have 3 and 4. Well, even though 4 breaks down further, you don't need to go any further, because the other factor is 3 again on the left-hand side here, and 4 and 3 don't have any common factors. So what's the same? It's 15 again. See, 5 times 3 makes 15. That is the largest factor that goes into those two numbers. So we would say 15 inches wide. Inches wide. And now, of what would that represent of each? Well, each of them could be cut at 15 inches, and we would get 3 from 3 15-inch widths from the 45-inch bolt, and we would end up with 4 15-inch width from the 60-inch bolt. So that's what we'd get from those. Well, let's take a look at our last problem here. It talks about that there are 100 senators and 435 representatives in the United States Congress. How many identical groups could be formed from all of the senators and representatives? So let's take a look at it. We've got the senators, and we've got the representatives. And so there's 100 of the senators, there's 435 of the representatives. So what we need to do is we need to break these numbers down. If you don't see any big numbers, then start with what you know. They end in 5 and 0. So let's do 5 times by 20 equals 100. 5 times by, now here we might have to do the division, 435. So 5 goes into 43 8 times with 3 left over. 5 goes into 35 7 times, so 87. Well, 87 doesn't have 2 as a factor, and 5 doesn't go into it either, so we can't break, it doesn't have any common factors with 20. So that means that we only have 5 as the greatest common factor. So we would have five groups. Now in those 5 groups, notice how we'd have 20 senators. So each group would have 20 senators, and we would have 87 representatives. Quite a few there. Well, those are the types of problems you're going to end up seeing on tonight's homework. Now, on tonight's homework, they're mainly going to just ask for what the greatest common factor was. So you're not going to end up having to use the information I had over here as much, but that kind of explains what's going on. So the main thing is using that greatest common factor with the problems that you see. Well, good luck on tonight's homework.